All right, so now let's go to the second section, and then we'll start at number 14. Using the definition of the derivative, find the derivative of square root of x. All right, so this requires, because it says use the definition, you have to use the limit as h approaches 0 of f of x plus h. Now that would be the square root of x plus h, and then you have to subtract the square root of x all over h. So this is the limit we have to find. Thanks to our knowledge of chapter 2, we can do this, right? I hope you can do that. When you have the square root function like that, and you have the difference of two square roots, what can you do? I like to use colors. In order to eliminate the square root sign, we can use the conjugate of the expression you see here. And of course, you have to be careful here. You have to multiply the top and bottom by exactly the same thing, right? That's the only thing we are allowed to do. For instance, we can't just multiply the top by one thing and bottom by something else, because that would change the quantity. All right, so you multiply by this. Everything I wrote in red looks complicated, but the whole thing is actually one, right? Because the top and bottom are the same. But now, because thanks to the properties of the conjugate, we can, let's go ahead and write down the denominator first. We can actually simplify the numerator drastically, because the numerator, a minus b, a minus b times a plus b becomes a squared minus b squared. So the top will be x plus h minus x, right? Wow, cool, because now you can see the h will cancel, x will cancel. And so this is, well, let me go ahead and write this down here. It's just the limit as h approaches 0 of, now the denominator is complicated. Who cares about, who says rationalizing the denominator is important? Sometimes it's okay to have a irrational, ugly denominator, because the top is very nice here, right? The numerator is just simply h. Now, of course, you can cancel that, thus eliminating the bad person. See, the reason I couldn't plug in h is because there was an h in the denominator, okay, as a factor. Now we have gotten rid of that troublemaker. So now the denominator is the difference of, or the sum of, two radical expressions. Right? Now you can plug in h is equal to 0, because that does not cause a 0 denominator anymore. So this whole thing becomes the square root of x, and then you have the square root of x. So that's 1 over 2 square root of x, otherwise known as 1/2 x to the 1/2 power, as we expected. Now we knew this by the power rule, but this is, if you didn't have the power rule, this is how you can solve this problem here. And in fact, that is, historically, that's how people figured out the derivative of the square root function. And then people thought that maybe the power rule applies even when the exponent is a rational one. Okay, now number 15, we are asked to solve one problem in two different ways. X not to the 9th is f of x, g of x is x squared. Let's try to find, so what's f of g? Of course, f divided by g is x to the 7th power. But let's take the quotient rule. Okay, first we are asked to use the quotient rule to find the derivative of f over g. Now later we can do this in a much more direct way, obviously, right? But this is just a demonstration that you will get two. You will use two methods, apply two methods on the same equation or the same function, and you do get the same answer as the derivative. Okay, so this will be g squared, that's x squared squared. The numerator will be 9x to the 8th, that's f prime, times x squared, minus x to the 9th times the derivative of g, which is 2x. All right, so this will be 9x to the 10th minus 2x to the 10th. Whoops, that's going too far here. Let me go ahead and erase this. You can simplify this further. All over x to the 4th, right? So that's, of course, 7x to the 10th divided by x to the 4th. That's known as 7x to the 6th power, right? And of course, f divided by g is, x to the 9th over x squared. This is x to the 7th. So the derivative is 7x to the 6th by the power rule. And of course, we are happy because these are equal to each other, thus verifying the validity of the quotient rule. All right, let's pause here, and then we'll go to the next segment as we go to number 16, because that's a graphing function. And I will graphing a function, and I will do that separately.